Hey, what's going on, folks? It's Mike here, and welcome back to my Modern C++ series. In today's lesson, we're going to continue talking about stream-based I/O, this time talking about working with files. Now, if you've been following this series in the past few videos, we've been talking about writing to standard in and standard out, which really, depending on your operating system, is just some sort of abstraction for writing out to some file somewhere where you can see stuff on your terminal or your command line display. But today we're going to open things up and start talking about stream-based I/O with files. And this can be really useful, and where it's useful, for instance, is if you have a lot of data that you need to sort of pass into a file, maybe chunk by chunk. This is where streams can really be valuable because you can do it in small little pieces at a time, or whatever sort of cadence you need. Or if you have an infinite stream, for instance, and need to write a lot of data to a file, you can do this. And this is where streams can be very useful versus just using functions like print, for instance, where you need a specific format to display. Streams allow you to chunk data into smaller pieces. So anyways, with that little explanation, let's go ahead and check out our favorite website, CPP Reference, and go ahead and dive into some more stream-based I/O. So I'm going to go ahead and scroll down here to the input-output library and stream-based I/O where we've been looking, and let's go ahead and have a look here. Now, again, here's our sort of format on how we do things here, but we're actually going to be jumping down here, which is really on the same level as this diagram here, and talking about output file, or OF, streams here. And of course, we will talk about input file streams when we want to read in input from the user, and of course Fstream, which is going to be an abstraction on just general file streams for input and output. So that's a little bit about the naming. So you're going to see we might include, for instance, Fstream in the same way that we loaded up IOStream, which brought in iStream and OStream for input and output. Again, usually we just include the Fstream when we want to do file-based operations. So anyways, with that little explanation here, let's go down to the file I/O implementation here. And I'm going to go ahead and just start with opening the Fstream tab up. And today we're going to be creating new files. So let's go ahead and look at ofstream to start here. And basically, this is, again, the high-level implementation here on file-based streams here. To whatever our file system is, so you don't have to use your operating system's low-level calls here. And again, if you want to look at the nitty-gritty details here, basically this just provides an abstraction over what would be like a file buffer, or just some collection of data, or a stream rather, an array of characters, if you want to think about it that way, that we can write to. So you can look at file buff if you want, and just know that there's some underlying abstraction here. And this is what allows us to use things like the stream operators to ultimately call some sort of write function. Okay, so anyways, let's go ahead and take a look at some of the things that we're going to do with output file streams. And of course, we have a wide version of that if we want to use wide characters. So again, if you're writing in a language that uses multiple bytes for a character, or other sort of advanced Unicode things, you might take a look at that here. Okay, so as far as getting started here, we do want to be able to just generally construct a file stream. And remember, we're going to be using some abstraction here to construct some sort of object here representing a file stream. That means if we're doing things, for instance, on the stack, we don't have to worry about closing the file. Now, we can close the file explicitly. It's probably not a bad thing to do in general, but because of RAII in C++, resource acquisition is initialization, it will take care of things like, again, closing the file. Now, there might be reasons where you do actually want to close the file and check if that fails, or there's something wrong with the actual file. But just know that you don't have to necessarily manually call it unless you're maybe doing some extra error checking. That might be something that you want to do. And somebody can correct me if they have another use case for calling close for the file, but that's the basic idea here. So anyways, let's continue looking at OF stream, or output file streams. And again, basically this is going to be our way to create a new file here. Okay. So some things that we're going to care about doing is open. With our actual constructor, if we take a look here, basically the way that we open a file is we provide a name here. If that file doesn't exist, we will create it. And then we have a few different operations for basically controlling what we want to do with that file. Is it going to be open for various operations, like just generally creating the file? Is it a binary file that we're writing out to? Is it a file that we want to create, and if it already exists, we just want to append to it? So there's going to be a few different options that we'll play around with and showing this video just so we can get used to the working with files here. And again, if you've been following this series, You've also seen some of the other member functions that are available, things like put and write for writing out characters. And we might actually play a little bit around with positioning too, because again, a file, and this will be actually useful to draw out. So let's actually do that here for a minute. Again, all file is, when we load up some file here, so here is my file that's opening, is basically I just have some integer or handle. So within my process here, and you've probably seen one of these diagrams here where you have, your stack down here, and, in some order, your data, your code, or let's kind of do this properly here, right? You probably have your text section here, which is your code, your data, pointer to the heap, maybe some other sections for exception tables and so on. But somewhere here, right, you've got your file handles. Let's go ahead and just file, and I'm just going to put, I'll abbreviate this, HWD. Sometimes that you'll see it like a handler or something like that here, or HND, HND for handles. But that's just basically, is a table that points to the files that are open. And then you can explicitly close them. But within this file, again, it's basically just an array of memory. So you can draw it as cells here. In practice, it's just a one-dimensional array here, right? And that's where that file buffer is. Okay, file buffer. That just has all of your bytes that you're writing out to, right? Because when we are writing to a file, we need to write them somewhere. We write them to this buffer, and ultimately that's where the data is being stored, right? Everything in our computer is basically just a linear array of addresses. And anyways, that's the sort of abstraction that we have here. Okay, so anyways, let's get into playing around with just a little bit of code here, just to do the basics here. Now, again, what sort of header file am I going to include? Well, again, Fstream here. Okay. Now, I know if you look at some code or maybe some compilers, you might see some different things where it's like, oh, Fstream. Again, Fstream is the high-level sort of interface for working with files. So work with files here. And let's go ahead and create a file here. Now it's worth showing, here's my directory here. I just have my main executable, okay, that I've generated here. But there's no files here. So let's just kind of keep that in mind as we do this first example here. And I'm going to use standard ofstream, give it a file here, and this is my constructor. Let's just call it something like myfile.txt here. And let's go ahead and start with that here. Okay, so let's go ahead and compile our program. And run it. It runs, and then I get my empty file. Okay, so it's been created here. We can open it up here. Again, there's nothing there. So that's as simple as it is. And we now have created a new file from our program by constructing it here in this mode here. Now, it's probably a little bit more interesting if we rerun this here and we go ahead and do something like hello, from Mike, something like that here. I'll put an end line here. Manually, let's go ahead and run our program again. And of course I need IO stream here. Again, the newer compilers are smarter to, they can usually tell you what libraries you're missing, which is really nice here. I actually really like this feature. There we go. Now we can use cout and our other stream-based IO here. Now, pay attention here to what's happening, and let's just, we'll correct this in a moment here. So let's go ahead and compile and run this. So we're getting hello from Mike here, because again, cout is writing towards this file handler that we have here. I'm going to draw just another arrow down here, which is std out, right? And that's got its own buffer of bytes that it's writing out to and managing that stream to. Okay, so if we want to write out to our file, what we're going to do here is instead of writing out to cout, let's replace that with my file. Recompile and run that. Oops, and it's not standard my file, it's just my file. There we go. So these helpful debug errors. And of course, yeah, you don't see anything printed out here, but if I output our little thing, my file, you'll see at line 1, hello from Mike has been written here. Okay, and now you'll actually see there is actually a few bytes here. If I list out my file here, let's see tree here for this actual file here. Okay, so it's as simple as that to write out to our file here. Now let's see what else we got here in our CPP reference, meaning that I want to go ahead and take a brief look at some of the member functions here. Oh, there we go. Let's scroll down here. There are a few other things that we might want to do, like check if the stream has been opened here. So something that I'll do here frequently, this is more important probably if I'm reading from a file, but I could do a check here and say if my file is open. Let's go ahead and just take a quick look at that here. It's just going to return true or false. Then we might want to write something out like file handler successfully created, or file handle to file, or however you want to sort of write it here. So let's go ahead and rerun this and recompile it. Oops, yeah, I gotta get rid of that. There we go. And then we get our output that was successfully created here. Okay, something like that. Now, reasons why a file might not be open, you could immediately think of some like, you ran out of disk space, or maybe you created a file that had some like name that was illegal for the operating system, meaning it's like too long, or using different characters or like symbols that you're not supposed to be using. So sometimes you might just want to check for safety. If you're looking for things to check, you do have those member functions available here. We do have the other things available. Let's go ahead and look at just from our basic ofstream stuff, things like put here. Okay, so let's go ahead and just do my file dot put, and let's go ahead and look at this function here, just as we always do here. And we could put a individual character here. Let's just put the letter W, I don't know, for win or something, and see if that writes it out here. So again, our file handler has been successfully created. Let's open up our file here, and you can see we have a W here, and then, hello from Mike here. Okay, so simple as that. You can use, let's go ahead and use write here. Inserts a block of characters. So it behaves as an unformatted output function. And basically, we just write out our characters here. Okay, so if you have a chunk of data, let's say here, a const char star here, you can write things out here. Okay, so no problem there. Let's try some other things here, like write out my file. Let's write out like 48 or something like this. Okay, let's see what happens here. I'm going to compile and run it. Let's go ahead and take a look at my file here. And I get the letter or the numbers 48 here. Okay, so I'm able to just write out these integers. We could do other things, for instance, like let's go ahead and try to write a character value here. A equals, I'm going to do the same thing, 48. Just replace it here. Let's go ahead and compile it, run it. And then all of a sudden, wait a second, what changed here? I compiled it fine. It said it created our file okay. And then we wrote out our character, our little string here. So, W, hello from Mike or whatever. And then this time, again, I'm writing a character 48. And then it's writing out my file with a 0 here instead of 48. But it did do 48 last time. So this is just a little thing here to keep in mind the representation that you're writing things out to. I often see beginners get a little bit confused with this. That's why I'm putting it out here. So if you don't know about ASCII numbers here, here's a website here, ASCIItable.com, which I'll often show them. And let's see what the decimal value 48 maps to. Oh, it is the character 0, right? Everything's just a number in our machine, including the representation of our characters. So, if you want to zoom in on that, feel free to, or check out ASCII table. So, you do have to think about the representation of these things. How do I want to treat this here? So maybe as an int, or, int 8t, something like that. Let's go ahead and try that. That's a fixed width type here that'll have a maximum range of, well, I guess since it's an integer, 127 or 128, I'll have to look here. But now if I output, oops, let's go ahead and recompile that. Let's try to run this again here. Again, I'm going to show you a few common mistakes that I see here. Let's go ahead and look at it in Vim. Again, it's still 0 here because this is, I believe, going to be typed to like a character here. So, sometimes folks will do like, let's do int 32. Let's see what that's typed to. And let's go ahead and run this now. Now we're actually getting 48 here because this is some like integral type that it's running to, right? Because this operator here, let's go ahead and look at our stream operator here, this one here for insert formatted data here. Let's go ahead and look at it, right? It has, if you look at all the overloads here, different overloads for how it's going to write out the different, well, primitive types here, okay? Now, most of you, I think, are just going to, if you want it to be an integer, right, you're just going to come here and say, hey, this should be a long or an int or, you know, something like that. And of course, you can find the int here or the unsigned int value over my shoulder here. There are those overloads. Okay, so that is the idea here. Now let's keep playing around with this a little bit more. So we've covered a few important topics like ASCII tables and so on, but I still do want to keep talking about this just so you have some sort of picture of what this abstraction is in C++ as well as other languages that probably use some sort of underlying buffer here. What if I don't want to write things one line after another? What if I'm writing some data here and I want to sort of jump to some other location here? Well, let's look at the positioning API here. And so we've looked at ways to write out data, basically, using, you know, formatted output here with the, you know, stream operators, put and write, but we do have these positionings here. So tell p returns the output position indicator, CP sets the output position indicator here, okay? So let's write a few lines here, just to make our program a little bit more interesting here. And let's go ahead and run this, and we'll review what's being written here. And let's see what's in our file here. Okay, so we have, you know, hello from Mike a couple of times here. Well, let's say we want to replace, you know, something in here, some position here. So maybe, for instance, I want to come and, I don't know, erase this W or something, or insert something at the very front of this file. Well, this is where we can use seek to set the output position indicator. Okay, where are we writing in the file here, right? I'll have to double check this, but I think seek p, or at least the way I think about it, or tell p, again, you think of it like position or the pointer internally in the file where you're actually pointing to. But let's go ahead and take a look at this function, make it just a little bit larger here. Maybe it is seek position or something here, but it sets the output position indicator of the current associated stream buff object. Okay, so remember we have stream buff or file buff if we're working with the file. That's where we are, the internal array. Again, that's this picture here. That is usually, you know, we think of pointing at the end here, but we can actually seek and position, you know, up here. Okay, so, in a different position, and then start writing our data from that position here. Okay, because it's just a abstraction over an array, basically. Okay. So anyways, we have a few different parameters here. So we have the sort of absolute position, the offset that we can set here. So position here would just be the absolute position, like set it to character like 0 or something. Let's actually play with that. And then we have other different offsets we can use with this different overload here. That'll say, okay, maybe I want to go to the beginning +5, the ending -5, or just wherever the current, you know, where we're currently writing, and then move forward or back from there. Okay, sort of like an iterator. I mean, that's basically this sort of what we're doing here. So let's play around with it. We'll keep some of the examples on the side here. Let me move this over there. There we go. And let's just go ahead and let's do myfile.seek p here. Let's go to 0, and let's go ahead and then do my file, and let's just write in an empty character here. Okay, something like that. Okay, let's see what happens here. Let's see if we did everything properly. So it compiles. Let's see how our file changed here. Well, now we got rid of that initial W and just put a space there. Okay, so we sort of erased that mistake here. If we write nothing here, let's actually see what happens if we try to write nothing or an empty character here. Let's go here. Let's compile. And we ran. Yeah, we still got the W here. We can't write nothing over there. So deleting might be a little bit tricky. I would just replace it with like a symbol or like a dummy value or something, and then you'd have to like copy and write it out somewhere else without that value. If you truly want to delete something, because you've got to reallocate that file buffer, the underlying file buffer, basically. But anyways, this is just a demonstration of how to use seek here. So let's just go ahead and let's just put a little empty space character here. Again, we could choose like arbitrary points here. My file.seek p Let's try like 32 here, and let's just go ahead and write a exclamation mark here. Okay, let's write a few of them. Well, let's just write one actually, and then we'll see what it does, just so you can kind of explore here. So I compiled and ran our program here, and then let's see what happens here. We seeked to 32, and then we wrote an exclamation mark. Okay. Yeah, stare at it for a second here, but there is Mike with a exclamation mark here. All right, so let's see what happens here. Let's go ahead and see if we write out 2 here, what happens here. Oops. And let's go ahead, and what I'm going to do here is just keep this file open here from our last run. Let's go ahead and compile and run it here, and then we'll see this time we got 2 exclamation marks. Okay. So it's instead of just M exclamation mark K, you get M exclamation mark exclamation, and the K is also erased. So we are overwriting our previous buffer here. Okay. So let's go ahead and do this a couple of times, just so you can again see that underlying it's basically like a file buffer is basically like a vector that we are overwriting here. Okay, and you can go ahead and see here. Eventually. Now the formatting is getting a little bit messed up because one of those exclamation marks is deleting, or not deleting, excuse me, it's overwriting one of the new line characters, so we can see this. So anyways, that's the sort of idea. That's some of the things that we can do with seek here, okay? And then of course you can use tell p to figure out the position here. Now let's just do one more with seek using the other overload, just so we've got basically everything in this video here. Let's go ahead and do my file.seek p. Let's see, what offset do we want here? And let's see if they tell us. Oh, this is gonna be, yeah, iOS is going to be the sort of namespace here. Let's go ahead and think about that a little bit. Maybe we could go, let's go to the end here. Instead of writing 48, let's write 56 or something. So let's do iOS base end. And then the relative offset here, let's go ahead and go here. It can be positive or negative. So let's go to the end, and then I don't want to go forward 2. Let's go like -2, and then let's write in my file, again, 56. Okay, here we are. Just to show a different number and see if we get rid of the 48 here. Well, let's do 42, just because that's a recognizable number here. All right, let's see what happens. So recompile. What happened here? Oh, expecting a... did I delete something? Maybe I deleted something too much here. Yeah, return 0. All right, there we go. Oh, what happened here? There we are. Semicolon, okay. All right, compiled. Let's see what we got here. And we got our 42, right? So we're basically going to the very end, scooting 2 positions forward, and then overwriting 4 and 2. Those are each 1 byte. And then we're overwriting things. Now, of course, this story can get a little bit more complicated if you're just like moving positions and you're working with wide characters and how those numbers sort of change. So things can get a little bit more complicated, you could say. But anyways, just wanted to show that as an example here. Now we've had fun here effectively writing our files in different ways here. But the last thing that I want to show you here is what if we want to basically append to this file here, okay? So what I'm going to go ahead and do here is let's go ahead and, again, just show you the basic file here that we've been working with. And I'm going to go back to the constructor here. And I want to look at this open mode here, okay? So again, currently in our constructor, we just sort of chose this, version here, and it just sort of gave us the, basic way to basically write out to a file here. Okay, so let's kind of scroll through this and see what else we got here. As far as the different types of modes here, which is what I'm looking for here. So in these different overloads here, for the mode, instead of just doing out here, which we could see is open for writing, you could make a file because it's just a bit mask open for reading and writing, and we're going to learn about bit masks shortly. That's one of the things we're building up to. Let's say we want to seek to the end of a stream before each write here. And basically what that means is open the stream and append to it. And you can see that the constant here is app here, or append. So let's go ahead and try this out, and you'll see the sort of, this is standard, : iOS, and then you specify the constant here for app here. So standard iOS, and then whatever the mode is here, okay? As can be shown here. Now let's see what else we got here. Okay, so let's go ahead and see. And then, of course, you do have truncate, which is sort of like an opposite of append, where it's like discard everything and just start writing to that same location. And you might use something like truncate, for instance, to instead of like just totally overwriting a file, like if you have a log or something, you might do that. Same thing with like append. That could be another use case if you just want to have this like giant file log that you're writing to every time you start an application or there's a crash, and then you send it and then clear the file or something. Those could be like different use cases for appending to a file. So anyways, what we're going to go ahead and do here is launch our program with standard iOS app here. And again, this was from our last run where we did a bunch of these file operations. And our file is going to get kind of wild because we're going to basically do this operation again. Write out a 48, seek to the beginning, write a 32, a bunch of exclamation marks, and then from the end, replace another 42 here. So anyways, let's see what happens here. Let's run our program here. Again, we've got the my file here, but it should be larger, right? Because we appended to it. Okay, we basically opened our file up again and rewrote to it. So let's go ahead and just as an experiment here, let's keep that file open. Let's go ahead and just run our program again and again and again and again. Okay, then I'm going to go ahead and exit this window here. And then let's go ahead and reload that file here. And there you go. It's much, much longer, right? Every time we wrote it, it got bigger and bigger and bigger. So it's as simple as that for append. If you don't want to overwrite the previous contents and just seek to the end of your file buffer. So again, that's this thing that we've been talking about. We just go to the end of whatever that internal file buffer is and just keep adding on to it. That's what appending is. Again, it could be very useful if you want to accumulate data in one place over time. But eventually you might want to write out that data and then, truncate it or something. So anyways, folks, hopefully that was useful. That is on basic output file streams. Again, just to do a little quick recap here. We've got our file that we open it up. We can change the mode here for appending, for input or output. We'll look at inputting or writing to a file, or reading, or rather reading from a file next time. So input mode here. We can check things and use the member functions like we've previously used with our streams here. We can write to our files. We do have to be kind of considerate of how we are writing to files if we're using things like the operator, which stream operator, which has a bunch of overloads for it. And then we can also play around with our files as long as we understand that, again, it's basically just a array underlying it, and we can seek to different positions here. Alrighty, folks. So hopefully that was useful. If you've been enjoying these stream lessons, feel free to check out courses.msha.io. You can check out my C++ course. You can check out all of these lessons here. Otherwise, in the C++ programming series here, it's a good way to track your progress. And it's the same lessons that you're watching here in a distraction-free zone. And then, of course, you can explore my other courses. So anyways, folks, hope you enjoyed that. Hope you learned cool things about, creating your own files now and writing out. And I think this is really one of the kind of fun things when you can write out files and save your work. I mean, remember when I was first learning how to program, how kind of magical this seemed to be able to write out data. And then, as we're going to learn in the next lesson, so hopefully you're subscribed for that, read back that data and then, write it out to the screen. And, all of a sudden you've got a computer that can read and write data and do cool things. So anyways, folks, that's it for this lesson. I'll look forward to seeing you in the next one. And as always, thank you for your time and attention.